Hello, everyone. Good morning. So as Ali said, I lead engineering at IBM for all our data portfolio on the distributed side, DB2, Netezza. And earlier this year, we introduced another product called watsonx.data. And you might have heard the last couple of days, yesterday and today, a few people talk about watsonx. But just to give a quick recap of what watsonx is. So it is an AI and data platform that we released back in May this year. And there are three main components of watsonx. The first one is .ai, which is, think of it as a studio, an AI studio, that you can use to help build, train, validate models. Not any models, but these are generative AI models, right? Large language models, foundation models, so on and so forth. Now, we have announced partnership with Meta. We have announced partnership with Hugging Face. So it's just not models that IBM comes out with, but it's also models that some of our partners have been working on, and we make those models available in our store as well. And of course, customers can build their own models. Okay? So that's watsonx.ai. The second piece of the puzzle is watsonx.data. Now, you might be wondering, why am I talking about watsonx, right? So I'll get to it. There's a lot of open source that goes into our products. And I just want to give you a background of what we are doing from an enterprise perspective and how we are using open source. So if you look at watsonx.data, the way we define it, it is a fit-for-purpose data store. And what we mean by that is we don't believe that there is one engine to rule them all, right? So some of our other competition out there do that. But we do believe for specific use cases, you may have to use specific engines. But how do you tie all of that together? So that is what watsonx.data is. It is an open lakehouse built on open source technologies. Presto, it is powered by Presto. But it also supports open table formats like Hudi and Iceberg. We even support Delta Lake. So that's watsonx.data. And it's deeply integrated with watsonx.ai. So when you have these massive volumes of data that you're bringing in and you want to train and fine-tune your models, we have a data store that goes with it that actually helps you not only store that data, but also helps you with model lineage, model governance, and all of those things. And the last piece of the puzzle in watsonx is watsonx governance. Now, we believe we are the first to bring out a governance for AI models. And when I talk about governance, we are talking about the U.S. government. I think they passed. It's not a law, but they passed a presidential decretive or whatever they call it, where they say if you are a company coming out with AI models and you're using it in your enterprise, you have to follow these general set of guidelines, rules, whatever you want to call it. The EU passed a law earlier this year. It's about 350 pages. Now imagine a data scientist reading that and making sure that the models that he creates adhere to those rules, right? It's not possible. So watsonx.governance actually helps you with that. During model creation time, generation time, fine-tuning, it actually takes your model and makes sure that you're following these rules that these government entities have set out to put out there. And of course, model lineage. Why did the model change? So are you able to build a model in a trusted, transparent manner, sustainable manner, right? So all of that watsonx.governance helps with, and we released it earlier this week. So that's the platform, watsonx, three pieces, AI, governance, and data. Now, if you look at, I'm part of data and AI in IBM. And we do everything related to data, everything related to AI. We have several products out there. And Data Fabric is one offering that we have come out with. And it's about 3 or 4 years, right? And if you look at everything that we do with data, you have data repositories that you can store data in, but how do you provide data governance? How do you provide lineage of data, right? Where do you track it? Every enterprise out there is doing it. Either they go to an enterprise vendor and buy software that helps them do it, or they're building their own mechanisms when it comes to data governance and so on. But we go more than data governance. We also do data masking, right? if a set of users is not supposed to see data and they query that particular table, how do you mask a particular column, right? So data governance, data masking, all those rules. We have done a few acquisitions in the space, Data Band, Manta, all of those things. But from an end-to-end data flow perspective, to the left here, you see all our databases. We have OLTP, we have data warehouses. Some of them are proprietary, but then we have watsonx.data, which is actually built completely on open source. Okay? And then how the data fabric ties everything else into watsonx. So just a very high-level picture on how we take this to market. Now, as I said, if you look at watsonx.data, right? So when we set out to build a lakehouse, and we've been looking at this market for quite some time, the last lake offering that we had was built off Hadoop back in the 2015-16 timeframe. And then in 2017, we decided too many players in very crowded space. And I think at that point, we were using like 24 or 25 different open source technologies, and we didn't have skin in the game. We were just taking open source into IBM, and we were using it. We created a product out of it, and we sold it to our customers, and we paid the price for it, which is it was very difficult to maintain, manage if you're not part of the community. So that's when we sunsetted that product, and we went into a relationship, into a partnership with Hortonworks, which later translated to Cloudera as well. So if you look at an organic IBM offering in this space, we lacked one. We had OLTP, we had warehouses, but we did not have a lake offering. And that's when we decided to go look at, okay, let's either acquire or build a lake. And this time we were very clear. We already own 3 engines. We have Informix, we have DB2, we have Netezza. These are all proprietary engines, as you may know, and proprietary table formats. So this time we wanted to make sure, and our customers were asking us for it, go completely open. And when we set out to build our lakehouse, and at that time we didn't know what we were going to call it. This was a year and a half back. One of our North Stars was we are going to go all in on open source. And this is not just using open source, but we want to contribute to open source. We want to create committers and contributors. And we want to work with the community in making it better, right? And that was what watsonx.data was. And we released it earlier this year in July. It's available both on premises, or if you want to call it private clouds behind the firewall, as well as it is available as a fully managed service on 2 clouds, both IBM and AWS. And customers can, of course, deploy it on Azure and GCP as well. Not as managed, but self-managed. So we have created a user experience around watsonx.data. But the thing is, think of it as I said, multi-engine based lakehouse. We support multiple table formats as well. So one of the engines that we support, obviously, is Presto. That is the heart of the entire offering. And we do support Prestissimo as well. We just released a version of watsonx last week, where we started supporting Prestissimo with Velox. We, of course, support Spark. And we have other IBM engines like DB2 and Netezza that if those customers want to use and they want to explore the lakehouse side of things, those work in the lakehouse as well. But the controlling point, or I should say the unification point, is the catalog underneath it. So we use Hive Metastore, and we, of course, made a lot of changes to it. That way, it is enterprise ready, if you will. We use Hive Metastore as the catalog for technical metadata. And no matter which engine you use, which user comes in and uses different engines and makes changes to the underlying data bucket, those get tagged in the Metastore. And that's how we maintain ACID consistency across the different engines as well. So some of the key components of watsonx. The bottom layer is the infrastructure and storage layer, right? Again, we are cloud agnostic. We can work in any cloud. We are available in 2 today as fully managed services, but a customer can get the licenses and they can deploy it, let's say, on GCP or even on Azure Cloud. So we are truly cloud agnostic. We are built on OpenShift, and that is one way. That's the container mechanism that we chose, and that's how we are able to release it simultaneously, on multiple platforms and multiple clouds. If you look at the metadata governance, I already mentioned this to you. HMS is Hive Meta Service is something that we use. It's got a lot of issues that we had to work on, we had to fix, and we have a huge roadmap that we are working on for the next 6 to 12 months, where we want to make it more robust for technical metadata. Table formats. So this was something which we struggled with a lot. So we started with Hudi, and we looked at Iceberg. So we do support both Hudi and Iceberg. We work very closely with some of our other partners here and members here in the Presto community, like Uber. And we've learned a lot from some of these partners. So we support both Hudi and Iceberg. We are making a lot of contributions back into Iceberg as well. Ryan Blue from Tabular, he was at the IBM Summit, I think a month or two back. He had a presentation about the close collaboration we have with them. But we also support Delta Lake. And I don't know if anyone from Bolt is here, but they were at the last Presto conference. They are a huge Delta Lake customer. All their format, their files are in, data is in Delta Lake format, but they love Presto. They don't want to use Databricks, whatever their engine is, Photon, or even Spark. They use Spark on Delta Lake, but they use it as a transformation engine rather than a query engine. And they love Presto, and we are working very closely with them. They are actually in production using Presto and Delta Lake. So those are some of the table formats that we support. And of course, from a query engine perspective, right? Presto is the heart of everything we do. So yes, we support other engines like Spark and some of our proprietary engines, but Presto is key to everything that we do. And that's a bet that we made early on, and we've been following the Presto community very closely. And we were super excited with everything that's going on in the Presto community, the users in the Presto community, and how far Presto has come over, I think a 10, 11-year period now. Now, if you look at the architecture, I did mention the multi-engine architecture. That is something which was new to us. If you look at some of our proprietary databases that we have, be it DB2 or Netezza, they are all stuck to the way storage, their own storage formats. You cannot easily scale down and scale up an engine. And by the way, these engines have been updated over a period of 10 years. They're all available as fully managed services on both IBM and AWS Cloud. Netezza is actually on Azure as well. So they have become cloud native over a period of years. But there were still baggage of the past, right? There are a lot of things that we had to carry from the past, which these engines were actually built for on-prem, not for the cloud. And that's where we were able to shake away and come with a model where, imagine at runtime, when you issue a SQL query to Presto, you can decide which Presto engine to use. If you are in development, you don't need to pay the utmost money for CPU and RAM and so on. You don't care about performance when you're developing something or testing something. You can choose a cheaper engine, right? Running on cheaper infrastructure. Versus if you're in production and you have SLAs to meet, dynamically you can actually choose an engine which is a lot more faster. You pay a little bit more money, but you will meet your SLAs. We couldn't do this with some of our older engines. We are able to do it, and that's what we call multi-engine, right? So you can scale Presto up and down. You can use multiple versions of Presto on different kinds of infrastructure. And then you can bring Prestissimo in for those use cases, so on and so forth. So that is what we call multi-engine architecture. Now, let's talk about open source. Of course, this is PrestoCon. We are an open community. We are now part of that open community. Now, what is our skin in the game? What have we done in the last year, 12 months? And how do we use open source at IBM? Now, this is by no means all of open source in IBM. Of course, we contribute a lot to the Linux Foundation from a Red Hat perspective. So we are one of the top contributors to open source, period, across all open source projects. We are, I believe, are either number 1 or number 2. But this presentation specifically, I will talk about the open source contributions that we have done around the Lakehouse, around Presto. So if you look at, when we started building this Lakehouse within IBM, we did look at some of the competing technologies. We looked at Dremio, we looked at Starburst, we looked at so many other people. Now, many other open source projects out there claim that they are truly open, but are they? That's the question. If you look at some of these open source projects, you have a big commercial vendor, and they control about 80-90% of what goes into it. And we have experience with that even from a Spark perspective, right? We work very closely with Databricks. We used to have a Spark Technology Center with them, but there is one entity that is actually gating what goes into open source, and that's not what we call open source. We want a community partnership, different entities, both commercial as well as other enterprises that are actually part of the open source community who are actually taking it forward. So these are two charts, and I believe Ali pulled this a week back, and these are year to date. Maybe we stopped it in October timeframe. So if you look at this is what we want to see in open source projects. We want community participation. Granted, this big blue there on the right side, that's not IBM, by the way. That's Meta. But we are working very closely with Meta. We have a strong relationship with them. Even outside of Presto, by the way, if you are following all the news that came out yesterday, we launched a partnership with Meta on the AI side as well. And we've been very closely working with Meta on other fronts as well. But if you look at some of these, we are just not talking about one commercial vendor controlling the entire open source ecosystem. That's not something we like, and that's not actually good for the open source community either. That's our take. And that's why we choose these two technologies, specifically Presto, and later on Iceberg as well. Now, some of the numbers, right? I believe we have several committers, 6, 7 committers right now, 15 plus contributors, and we want to increase this. Now, remember the story I told you about big data, and Big Insights was the product that we had launched back in 2015, 2016 timeframe. We did not have any of this, right? We were not contributing back into open source. So one, we didn't have a say. We couldn't guide, and we couldn't bring our viewpoint to the table because we were not part of it. And two, our customers suffered at the end because they wanted things in open source which we were not able to directly contribute because we were not playing in that game there. So this time around, we did an acquisition of a company called Ahana back in the first quarter of this year, March, April timeframe, I should say. And we've been working very closely with Ahana even before the acquisition. We were working with them in trying to understand Presto, trying to build relationships with the community and so on. But as part of the Ahana acquisition and training IBMers, we have made several contributions into the Presto Foundation. That last number there, so that is mainly into Prestissimo, specifically with Prestissimo and Velox. We have raised about 100 PRs, and this is in a short span of about 5 to 6 months. And I sincerely want to thank everyone on the Meta side for working closely with us, and on the Ahana side for actually helping us get up to speed, because we don't want to open PRs with low quality code. So we have mechanisms even within IBM, even before we open a PR and commit that code into open source, we have mechanisms where we make sure that this is quality code and it makes sense for the community. And it's not about we creating something and keeping it to ourselves. We want to contribute that. That's the whole purpose of being part of the Presto community. And some of the contributions we make, everyone's going to benefit from it, not just IBM, not just IBM customers, right? So these are some of the metrics that we've been tracking very closely. Now, if you look at Presto at IBM, right, and this is part of the integration of Ahana, what we gained from them. Ahana had done a great work in the last, I would say, 2.5 years, working with the community, working with customers, working with Meta, working with Uber, and they had created a lot of caching mechanisms, fine-tuned configurations, and so on. So we were able to bring all of these back into IBM, and we were able to make it part of the watsonx.data product. Now, I keep saying watsonx.data is built completely on open source. It is true open source. We use Presto. The version of Presto which is released, that's the version we use, right? There's nothing more to it. But where we add value is the surrounding things around it. Our customers are banks. Our customers are financial institutions. Our customers are healthcare institutions around the world, airline industry, telephone. So these are all customers that care very much about security. Security is the number one thing that is at the back of their mind. They do not want data breaches. So when IBM sells a piece of software, we actually stand behind it. When a data breach occurs, we stand behind it. And we say, there are remunerations that we pay those customers if it's our fault. That is the level of confidence we have around the products that we build. So it's very important for us to take what is open source and make sure we are addressing security issues, security vulnerabilities, and so on. And we push these back into open source, and this is how everyone benefits. Now, there might be some users who are behind the firewall who might say, I don't care about it. But I can guarantee you, if you go to your CISO or BISO, they will have a different view. Most banks that we work with, they are both on the cloud and behind the firewall, and they have the exact same metrics that they put their containerized software through when they scan their containers for vulnerabilities, and they don't have two different measurements, one for the cloud and one for on-prem. So again, these are some of the areas that we have been contributing back into open source, fixing critical issues, high security, severity issues, and so on. Now, where do we want to take this, right? So some of you might agree, some of you may not, but Presto was really not created to go after warehousing workloads, right? It's a distributed SQL engine created for whatever purpose. Customers use it for whatever purpose. But our take is that we do feel it's a very, very strong entity, offering that we can actually go to warehousing customers and say, stop using warehouses, use this. And Prestissimo helps us with that, right? So when we were benchmarking Presto, we ran TPCDS benchmark against the Presto engine. It gave a bad feeling to some of the ardent Presto lovers. But if you see Presto, it is slow. From a Java perspective, for warehousing workloads, it is slow. And again, full disclosure, it was not meant to run warehousing workloads, so we understand that. Now, the question is, what can we do? Can we make Prestissimo work for warehousing workloads, right? Customers don't want 10 different databases. They want one data store where they can use multiple engines and still benefit one single copy of data and not keep copying data all over the place, right? So we did some initial benchmarking. The first line there which says about 70% of the TPCDS benchmarks, we were actually faster than a competition. That competition was Dremio, right? Again, a proprietary engine, iceberg table format. But about 70% of TPCDS, we didn't do anything. We just took Presto, ran it. 70% were actually faster than a proprietary engine, which is Dremio. Those are good results, I would say. The second metric there, about 60% of the TPCDS queries, I think we have, 103 queries in TPCDS? 60% of them were even faster than Snowflake's external tables. We were shocked and surprised when we saw those results. So there is a lot of capability in this engine, and this is pure Presto, Java-based version of the engine. Now, if you look at the right side, right, post-GA, what I've been doing, and GA is general availability that we released back in the July timeframe. So in the last 4 months, we've been using Prestissimo. We've been working with partners like Intel, with Velox, and we've been trying to see what can we do here, what can we do better to get better performance. And what we found is there were gaps in the optimizer. There were gaps in some scalar function. There were gaps in runtime itself. You could run it for smaller workloads, maybe 1 terabyte, 10 terabyte, but once you scale it up to bigger workloads, queries would fail, or when queries returned results, they were wrong. How do we know they were wrong? Because we have other engines we can test it on. These are standard TPCDS benchmarks, right? So that's what we wanted to go address, and that's what we've been working very hard the last 4 to 5 months. Now, if you look at the areas, so Prestissimo, by the way, we've already released what we call a tech preview to our customers because we want our customers to use it within watsonx.data. When a customer has an application that is coming in and issuing a query to Presto, we want that customer to have a choice. Do you want to use Presto to run that query, or do you want to use the Prestissimo side of things to run that query, right? So we did release it as a technical preview last week, and we are already hearing some really good results. But if you look at this slide here, these are some of the areas in Optimizer that we are working on. This is not a full exhaustive list. As I said, we have opened about 100 plus PRs. 75, 80 of them have already been merged. And you can actually go see all the areas that we are working on. And we are, again, from our partners in the community, Meta has been using Velox and Prestissimo on several hundred, if not 1,000 node clusters for a long time. Denodo has been using it. ByteDance, I think, has been using it. Intel, they have been doing a lot of work with Velox when it comes to Spark, right? So we are partnering with them on the Spark side as well. So a lot of good things going on. And this is not something that one entity can do. We don't want to spend 500,000 resources and spend the next 5 years trying to fix some of this. So there are areas that we feel we have the experience, especially around Optimizer, query performance, and stuff like that, where we bring value to the table. But we want to work with the rest of the community, and we want the community to see Presto not just as a distributed query engine, just for federation use cases, but it can really run warehouse-level workloads as well. Maybe not today, but it's getting there. So when we look at performance, right, it's not just about taking a query and saying, oh, can this query run 2 times faster or 5 times faster? It's also about the cost of hardware. And I missed the Meta keynote this morning, but someone told me that Meta shared some numbers where they were able to use Prestissimo and Velox and massively reduce the amount of hardware they were using for the same use case, right? That's amazing to hear, and that's exactly what we want. Customers want to save money. So if you're using Databricks, if you're using Snowflake, right, paying millions of dollars, how can we run the same workload with this technology at half the price when it comes to infrastructure? That is what interests us, right? And these are some of the areas when we look at query performance, it's not just about can this query run faster, but can it run faster, consuming lower CPU time, lower hardware, lower memory, right? How is the latency? Is there improvement in the latency? These are all the things that, again, DB2 just turned 30 years this year, by the way. So we have experience in this area, 3+ decades of experience in this area, and these are all the areas that we are looking at trying to fix the Optimizer runtime. It's just not the Optimizer, it's also the runtime, how data sharding is done, how caching is done. It's the entire end-to-end. And this is just a quick example. I think this is query, I don't know what query this is, query 95, I think. And as you can see, and these are direct screenshots from the Presto UI itself. The left side is the Presto Optimizer and its query graph. And the right side is the IBM Optimizer with our query graph. And our goal is, over a period of time, how can we bring these changes into open source Presto? So some of these queries with a specific set of hardware wouldn't even run. They would run into out-of-memory issues, but they completed with the IBM plan. And by the way, the IBM plan is just generating a plan. Query comes to Presto, Presto hands off to our query graph model that does the computation, rewrites the query, gives it back to Presto, and Presto executes it. And we are seeing, in some cases, 7 to 12 times more performance, better performance. Queries run 7 to 12x faster just by a simple query rewrite. Just think about that. So we are super excited with the capability of the engine, and that is where we want to spend our time on fixing the gaps, addressing the gaps, and making it a very strong and robust engine. Now, when we released back in July what we call watsonx.data version 1, we took that as the baseline. That was the industry baseline, OSS, Presto. We took that as a baseline. And we said, OK, let's go with that. And we did both 1 terabyte, 10 terabyte, and 100 terabyte benchmarks. And this one, what I'm showing, is a 10 terabyte. And the version 1.1 that we released last week, so this is with advanced caching, new configurations with RaptorX, all of these. we're about 1.3x faster, just open source to open source comparison. On top of that, the same queries, if you run it to Prestissimo with vlogs, we are about 2.4x faster. And on top of Prestissimo, if we bring in our query graph model, where we rewrite those queries, right? And by the way, these rewrite is not, you don't manually copy this query, present it somewhere, and copy it back. This all happens in milliseconds behind the scenes, right? When the query is rewritten and still executed by Presto or Prestissimo, we are about 3x faster, right? So in a short 4-month span, we have shown what we can do with this technology. Again, we are super excited about the technology, very strong, very robust. But once we continue to address some of these gaps and bring in new features, I think it can beat any technology out there from a data warehouse perspective. Okay, so the storage acceleration mentioned here, IBM has a storage team, and not just from the hardware perspective, but from a software perspective, we have software-defined storage, and there are storage level caching that we can enable more than application level caching. And in some of our early results, testing with our own CIO's office, who used to use Starburst, by the way, and now they moved to Presto. And our own CIO's office, we find about 3 to 5x better performance just by turning the storage caching on, right? So it's work in progress. It's not some numbers that I could share with you right now, other than the limited use case that we did with the IBM CIO's office. Although I say limited, we are 300,000 plus IBMers, so if it works for our CIO, it should work for anyone, right? So again, a lot of work going on in some of these areas. So I'll end with one partnership. Again, we partner with so many other people in the industry out here, but we've been working very closely with Intel for more than a decade, by the way. Many people might not know this. So Intel helps us benchmark our software on their chipset, both released and upcoming chipset as well. The reason the work that we do with Intel is very important for us is because if you are on a cloud, be it IBM or AWS cloud, and if we have benchmarking mechanisms against newer chipsets and different generation of chipsets, we are able to reduce the footprint of infrastructure required, compute required, by doing the right kind of benchmarks with help from Intel. So they come to us and say, go with our 4th generation. It's only 5% more expensive, but you're going to get about 80% better performance, right? So those are all the kind of things that we are working with Intel closely. There will be a lot more announcements coming out in the near future. So I want to thank every one of you. We are super excited to be part of this community. And again, this is, like I said, we have other proprietary databases within IBM. But in my career, in the data industry, this is one of the best times, I would say, for data lakehouses, especially because of technologies like Presto and Iceberg. And it's an amazing community we've got, right? I mean, IBM was a little late to the game when it came into the Presto community, but some of the partners that we have, some of the friends we have established in the last year, it's been amazing. So with that, thank you, and have a good conference.